Welcome to 5.4. We are going to derive sine of a plus b. We're going to start with sine of a plus b, and we're going to use the cofunction identities. So we're actually going to use this one right here, where we have the sine of a is the same as the cosine of 90 degrees minus a. So our a here is actually a plus b. So we'll be plugging in a plus b for a into that identity. So we have that sine of a plus b is the same as cosine of 90 degrees minus this angle, which is a plus b. Now we need to distribute the negative to a and b. So we get cosine of 90 degrees minus a minus b. We're going to group 90 degrees minus a as one angle and apply the cosine of a minus b formula, or the couscous formula as I like to call it. So we get cosine, cosine, sine, sine, and the first angle is 90 degrees minus a. The second angle is b. Again, first angle is 90 degrees minus a, second angle is b, and because it's a minus here, we flip it to a plus because the minus in cosine a minus b is a plus on the other side of the identity. Now we are going to use the cofunction identities again. Notice that cosine of 90 degrees minus a is the same as sine of a. And sine of 90 degrees minus a is the same as cosine a. Now we drop the rest down, and here we have the sine of a plus b identity, which states it's the sine of a times the cosine of b plus cosine of a sine of b. Because I like to call the cosine of the sums and differences the couscous formulas to keep with the same food trick, I call this the sine sandwich. So it's kind of like a sub sandwich where you take it and you fold it. So it's like the cosines match, the sines match, so it's like it's symmetric. But notice the AB pattern still holds, AB, AB. Similarly, we could also derive the sine of a minus b by finding the sine of a plus negative b, applying the sine sandwich formula or the sine of a plus b, we get sine of a cosine of negative b plus cosine of a and sine of negative b. Because of our negative angle identities, we have that cosine of negative b is the same as cosine of b, but sine of negative b is the negative of sine b. Bringing the rest down, we end up with sine a cosine b minus cosine a sine b. So now when you compare and contrast the sum and difference identities for sine and cosine, we see we have the couscous pattern here where it's cosine, cosine, sine, sine for cosines. And then for sine, it's sine, cosine, cosine, sine. And then we have for the cosines, the signs are opposite, whereas for sines, the signs are identical. Now let's derive tangent of a plus b. So we'll start with that, tangent of a plus b, and we're going to use the quotient identity, which states that tangent of theta is sine theta over cosine theta. Notice that my theta is a plus b, so it will be sine of a plus b over cosine of a plus b. Now we just simply apply the formula for sine of a plus b, or sine sandwich, and the cosine of a plus b, the couscous formula. So from here, this would be an acceptable formula for the tangent of a plus b. However, it's common for it to be written differently. So in order to get it in that form, we're going to do something we don't normally do, which is multiply top and bottom by 1 over cosine a cosine b. We need to make sure that we distribute this 1 over cosine a cosine b to both terms in the numerator and both terms in the denominator. On top, the first term, the cosine b's will cancel. The second term, the cosine a's will cancel. So we will get sine a over cosine a plus sine b over cosine b. In the denominator, the first term, both cosine A and cosine B will cancel to give us 1, and in the second term, we will rewrite as sine A over cosine A times sine B over cosine B. You might notice that sine A over cosine A can be written as tangent A, sine B over cosine B can be written as tangent B. In the denominator, we get 1 minus sine A over cosine A is tangent A, and sine B over cosine B is tangent B. Therefore, we get the formula for tangent of A plus B is tangent of A plus tangent of B all over 1 minus tangent of A times tangent of B. I hope you enjoyed the video. See you next time.